Lesson number 5, magnetic fields around wires. I know it's hard to believe, but if you have a wire, a magnetic field develops around the wire, and if you look in the walls here or whatever, we can actually detect the magnetic fields from the wires that are actually in the walls. So if you use a metal detector, for example, it's looking for the magnetic field created by the metal. So if we look here, if we have a wire, like so, the magnetic field is basically forming a circle around the wire. So if we look anywhere along the wire itself as we move this, if we look at this circular pattern as around it, the field lines actually wrap around the wire and form circles around the wire itself. I'll attempt to draw this on the board. So if I was trying to draw this, I would try to make circles, loops, around the wire at various places. So I guess something along these lines. So we come around, circle around, making loops, okay, at every point around the wire. Now there's a rule. To determine forces using the right-hand rule, we were using our hand with it flat. Field lines this way, thumb for the velocity, and the forces come out of my palm. This is for forces. This is called right-hand rule number 1. Right-hand rule number 2 is what I'm going to use to determine the magnetic field around wires. This time I'm going to curl my fingers around like so. So if you look at my thumb and my fingertips are above my thumb, kind of in a curled fashion. So I want to determine the direction of the magnetic field lines. What I'll do is take my thumb and I will draw these. Now, my thumb must go in the direction that the current is flowing. So in this case, the current is going to flow towards the board, so the electricity in the wire is headed towards the board. So basically all I'm trying to do is draw these circles and figure out what direction they're going. So I take my thumb, put it on top of the wire in the direction that the current is flowing, bend my fingers, and then start to wrap my hand around to form the circle around the wire. Notice that the circle is going around the wire, but it also has direction itself. Even with the wire, if you notice, the arrows are pointed downward. So when I take my thumb, when I reach this point, my fingertips are pointed downward. If I spin around, I'll go around to the top, notice that my fingertips are pointed this way and form the direction at the top of the circle. When I'm underneath it, I take my fingers and my fingertips are pointed towards the windows. When I turn it more, so each time I do this, I'm trying to draw the circle and the direction for the magnetic field lines. This is how we draw them. So on the board example, if the current were flowing in this direction, so if the current is flowing this way, I would take my hand and then wrap it around like so. So on the very top, the field lines would be traveling in this direction. At the very bottom, they would be traveling in this direction. And voila, here, 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 and keep drawing them in the proper direction as they loop around, forming these loops. This is called right-hand rule number 2. Notice that it's not used for forces, it's used to determine magnetic fields by drawing circles using my thumb and my curled fingers. Right-hand rule number 2 is for magnetic fields.